The cryogenic hydrogen powertrain that will transform propulsion. It could solve the biggest problem plaguing electric aircraft. In the ongoing fight against carbon emissions, air travel has a particularly bad position because of the industry's reliance on high speeds, light weights, and fossil fuels. But Airbus's new superconducting powertrain, which is cooled by super-cold liquid hydrogen, may solve some of those pressing problems. The new system, named Advanced Superconducting and Cryogenic Experimental Powertrain Demonstrator, ASCEND, is in ground-based demonstrations. The 3-year project aims to show that an electric or hybrid electric propulsion system can be more than 2 to 3 times lighter than a conventional system without compromising a 97% powertrain efficiency, Airbus says. If it works, ASCEND could be a landmark achievement in future-looking aeronautics. The snag facing electric aircraft designs mostly comes down to a matter of weight. On the ground, cars can add up to 1,000 pounds worth of batteries. But in the sky, that could mean the difference between an aircraft flying or sinking. Passenger planes in particular are already a very finely balanced system. Airbus's hydrogen powertrain is made up of a superconducting distribution system, a cryogenically cooled motor control unit, and a superconducting motor. The overall goal is to put the entire powertrain into a superconducting state, meaning with virtually no electrical resistance. At that point, its power density could greatly exceed the burden of the added weight of electrical power. That's why liquid hydrogen is key, Airbus says. FA cold source at 20 kelvins, minus 253.15 degrees Celsius, such as liquid hydrogen, is available on board. It can be used to cool the electrical systems. The superconducting components can then work to significantly improve the power density of the electric propulsion systems. For now, the system is only on the ground as engineers work on it for demonstrations. If ASCEND makes it to prime time, it will approach parity with traditional fossil fuel aircraft, Airbus says. Airliners are a special case, but Vancouver-based Harbour Air is working on electrifying its fleet of small local planes. It's possible to do, it's just difficult or impossible to scale up to jumbo jets. Certainly no regular electric plane can compete with something that runs on superconducting electrics, so if Airbus brings ASCEND into its fleets in future decades, the manufacturer will essentially have the sky to itself. How did this all come about? Well, liquid hydrogen is already considered the leading candidate to transition commercial airliners away from fossil fuels. That's for several reasons, but liquid hydrogen is able to slot into existing engineering in a way electric propulsion hasn't before now. What Airbus is suggesting is a marriage of hydrogen and electric. Liquid hydrogen has to be super-cooled to be used at all, and Airbus realized that cold hydrogen itself became a new available resource. It's like air-cooled car engines, which utilize the air rushing through the engine anyway and turn it into an asset.